Lesson 5-9, Powers of Products and Quotients. All right, last chapter we learned a little bit about exponents. Today we're going to use those same rules, except we're applying them to when we have products and quotients. All right, so example of a product is in a parenthesis. If I have two things being multiplied, that's a product, and that is raised to a power. We're going to learn how to solve that. When we solve, it's important we remember what we learned last chapter. For example, in number 1, 2 squared to the third power. When I have a power to a power, we learned the trick is just multiplying those exponents. So this number 1, 2 to the second time, or to the third power, would be 2 to the sixth, which I can simplify, to 64, and that would be my final answer. All right, keep those rules in mind. Here we go. All right, here's an example of a product, 4 times 2, being raised to an exponent. Now, anything raised to an exponent, I know that 4 times 2, right here, is just being multiplied together 3 times. So, another way I can look at that, if I pull all the 4s out of those groups, I have 3 4s and 3 2s being multiplied. Based on the commutative property, I could reorder those numbers. Now with the associative property, I can regroup. So now I've regrouped those 3 4s and regrouped those 3 2s. Finally, with exponents, I can write that as 4 to the third times 2 to the third. In other words, in order to solve this product raised to an exponent, this 3 can be applied to the 4 and can be applied to the 2. I would have to simplify to get my final answer. So in other words, to raise a product to a power, raise each factor to that power. In this problem right here, 5 and 3 are factors. This exponent is going to be applied to each factor. 5 to the 4th times 3 to the 4th. Let's do an example together. Simplify 4 times x squared to the third power. We just learned that if we have a product in a parentheses raised to an exponent, I can apply this exponent 3 to each part of my product. Let's break apart this product. I have 4 being multiplied by x squared, and all of that is raised to the third power. I'm going to bring that third power and apply it to the 4 and to the x squared. That'll look like this. Now I can finish simplifying. 4 to the third is 64. X squared to the third power, that's a power to a power. I'm going to multiply those exponents. X to the 6th. One more example here. 2 times 3 to the third power. Now, some of you could just multiply in the parentheses and get 6 to the third. 6 to the third is 216. Let's check based on the strategy we just learned to see if we get the same answer. The exponent can be applied to each of the factors. 2 to the third times, 3 to the third. 2 to the third is 8. 3 to the third is 27. If I multiply those together, I indeed get 216. All right, what if when we're doing this we have a negative sign? Well, let's find out. In A, this negative is in the parentheses, meaning we include it with that 5. So negative 5x is our product. If I break it apart, I have negative 5 being multiplied by x. I'm going to square both of those parts because the exponent goes to each factor. So negative 5 squared is 25. X squared is x squared. My final answer is 25x squared. Now in B, the negative is on the outside here. So I'm just going to deal with that later. We're going to times our final answer by a negative 1. This exponent of 2 is going to be applied to the 5 and the x, so not the negative 5. So now 5 squared is 25, x squared is x squared. I tack on the negative. Final answer is negative 25x squared. So that's the difference between these two. One, in A, the negative was included. In B, it was on the outside. Let's do one more. A, this negative is included with the 2. So this 4 is going to be applied to the negative 2 and to the y. Negative 2 to the 4th power is 16 times the y to the 4th. Now if I do b, the negative is on the outside. That negative 1 will be applied at the end. The 4 is applied to the 2 and to the y. Final answer, 16y to the 4th, but the negative 1 makes it negative. All right, now raising a quotient to a power. We just did 2 examples of a product to a power. Now we're going to talk about when you're dividing something and it's raised to an exponent. So right here, 2/3 to the 3rd power. That's a quotient because a fraction is also a division problem. 2 divided by 3. Now we can notate this as 2/3 being multiplied 3 times. In other words, I have 3 2's on top, which I can notate with an exponent of 3, and 3 3's on bottom, exponent of 3 on bottom. Notice this 3 just got applied to both the top and bottom of my fraction. Super easy. To solve, I would need to find out what 2 to the 3rd is, and 3 to the 3rd is as well. That's my simplified answer. Let's do one together. All right. Find the area of the square tile. Now, we know to find the area of a square, it's side times side, or side squared. So if they tell us that one side is 3 over b, to find the area of this to find the area of this square, we need to square one of the sides. So we just learned that if I have a quotient raised to a power, I can apply that quotient to the top and to the bottom. Final answer, because this can be simplified, 3 squared is 9 over b squared. That's the area of my square tile. Let's do another example, A. All right, negative 2/3 to the 4th power. Remember, when I have a negative rational number, like I do negative 2/3, I can put that negative up on top with my numerator. So I'm going to rewrite it like this. It's a quotient raised to a power, so I'm going to apply that power to both the top and the bottom. Negative 2 to the 4th over 3 to the 4th. Now, negative 2 to the 4th, once you solve this, is 16. 3 to the 4th is 81. Now I'm going to check if I can simplify, and I can't. So that is my final answer. All right, last thing I'd like to show you before we move on to the questions. If I have something raised to the negative power, this is what we do. Last chapter we learned that any negative exponents, we can rewrite them as a positive exponent by using the multiplicative inverse. So a to the negative 2, I can make positive by putting it on the bottom, and that negative 2 becomes a positive 2. So just keep that in mind when we go to solve this example. If I have a product, 3 times 5, it's raised to a negative power. I'm going to first put all of that on bottom so that my exponent becomes positive. Now I can do the simplifying. 3 times 5 is 15, raised to the 2nd power is 225. All right, now it's your turn to try. I have 4 problems for you to attempt. 1, 2, 3, and 5 problems. Make sure you pause this, get these written down, and bring them to class.